So good evening, everyone. Today we will start topics surrounding geography, right? So geography and related to um, geological aspect also. So in this, we are going to see these 6 different topics, so which uh, are going to discuss in detail. So first, we'll move on to polar stratospheric clouds. Okay. So what are polar stratospherical clouds? So why it is in news? Okay, so clouds in polar stratosphere. So how they are formed? So you know that in stratosphere there are almost less amount of clouds, right? So why these or how these polar stratospheric clouds are formed? Anyone? So unusually we had an Arctic display of polar stratospheric clouds recently. So that's the reason why we had this in news. So polar means it can happen both in Arctic and Antarctic. Yeah.
Yes, sir. Over the poles in very cold regions, so they are made up of ice particles.
Ice particles, okay.
So,
altitude?
sir, about in stratosphere, about 19 to 30 kilometers.
Okay, so it will be around 25 kilometers. So it should be okay. Fine. Okay. Then
Sir, basically the cirrus clouds are the stratospheric cloud among the clouds, like cirrus.
Okay. So this will happen when you have around typically low temperature. So temperature around say minus 78 degrees Celsius and below. So we can expect these clouds which have to be in this particular stage. So what these clouds actually composed of? So you know that when very low temperatures come in, so automatically the water which is there available there, so it goes it will be more of icy nature, and when it combines with the nitric acid, so these clouds are formed with displays. Okay, so this is a combination what it happens. So in this particular combination, when this nitric acid is mixed with water and it is going to be forming the cloud, so these colorations and displays are available at that particular time. So automatically what happens, this results in one of the most important consequences.
The ozone depletion.
Ozone depletion, right? Ozone depletion, because it is going to happen in the stratosphere region. So naturally ozone depletion will be there. So what is the reason for the ozone depletion? It is because of the chemical reaction. So the chemical compounds which are found, especially nitric acid, or it can be of others like chlorine, bromine. So all those are definitely, it is going to cause ozone depletion. Okay. So why they appear with iridescent or coloration? Because of the components, okay, chemical composition what we have. So we call it as mother of pearl clouds and all. Okay. So when it will be visible?
Sir, winter months.
When it is so winter, okay. So generally winter, especially twilights. Okay, so twilights, during that particular time of twilight, so we have that particular illumination which is happening. Okay, fine. So recently we had some ground informations through satellites which monitor climate change and other stuff. So they try to study about these polar stratospheric clouds. And most importantly, it is one of the indicators of climate change, and especially Montreal Protocol, which talks about the CFC components to be eliminated, and similarly the Kyoto, which wants to bring back the emission levels. So all these have one of the greater contributions in these aspects. So try to link it with stratosphere. So especially stratosphere is in news for very long period of time, and for various other aspects also. We have sent even missions for studying stratosphere, which we have seen already in the science and tech part. Okay, fine. So check out with these aspects. Similarly, along with this, also read ionosphere. Okay, so ionosphere again, that was in news for various reasons, which we saw in the science and technology part. The sun's emission and its waves, corona waves, and so on. So all these disruptions which is caused by electromagnetic radiations, all these were in news in ionosphere also. So stratosphere, ionosphere, so both you try to have a look upon. Okay, fine. Now, so Antarctic circumpolar current. So why it is in news? So why it is in news? So recently it is discovered that it became the world's strongest ocean current. Okay. So the world's strongest ocean current, which encircles Antarctica. Okay. So that's a reason why it was in news. Okay, in the southern ocean. Okay. So how this ocean current is stimulated? So how it is starting? So which is the main cause for this particular Antarctic circumpolar current to accelerate?
So the westerly winds.
Westerlies. Okay. So westerlies. So since westerlies is in news, try to read about westerlies also. And also westerlies, last time they didn't ask, especially when we had the extended La Nina. This time, since it is a peak of El Nino time, so they can ask about the El Nino La Nina with respect to westerlies. Okay, so try to read about westerlies. So westerlies is the reason why we have very strong southern winds. Why westerlies is also found in the northern part, northern hemisphere, but why the Antarctic circumpolar wind is so strong than the northern winds, northern currents?
So like in northern hemisphere due to ITCZ, like shifting of ITCZ. So like usually in summer and all, the westerly, the intensity of the westerly got decreased. But in southern hemisphere, due to the Antarctica, the intensity of the westerly remains constant throughout the year.
Why?
Because
No,
in
less
northern hemisphere, the heat.
There is no much of continent, right? So there is no much of continent. It is completely large amount of water mass is available. So it is becoming constant, and there is no much change in the intensity of the westerlies. So naturally, that westerlies stimulates the acceleration of this Antarctic circumpolar current. Fine. Okay. So what does this particular current, circumpolar current, has an effect on these region?
Maintain heat budget and also.
Okay, so they try to have implication on sea temperature. Okay, fine. That is ocean temperature. Then what else? Speed of the current, right? So with this particular speed of Antarctic current, naturally the other currents will also have its own influence. Okay, then fine. So biodiversity, because the upwell of ocean currents will be there, especially warm and cold, where water mass will be moving. Fine. Then it also have an impact on the ice sheets, right? Because this strong current, so naturally there is a drift. So we call it as a drift current. So when they are drift, naturally they will have a large impact on ice sheets, right? Antarctica, ice sheets are there. We have discussed it before. We have ice sheets, ice shelves, okay, icebergs. So naturally it will have an influence upon them. Okay, what type of impact or influence it can have over Antarctica?
Like some melting of ice and all.
So melting of ice can be rapidized, right? So that we saw. So how Antarctica's ice shelves melt very faster. So when they melt very faster, they have one of the world's largest conglomeration of ice. So when they start melting, what will happen? So you have more amount of sea level rise. So automatically the sea level rise will pose a major threat. So when you have sea level rise, automatically you have coastal erosion, right? So you have coastal surge, submergence, right? So all these factors increases. Okay. So
Relative coral reefs.
coral reefs will be affected, right? So all these aspects can happen. Okay.
Sir, can you please explain the relationship between this concept and El Nino?
So this concept and El Nino, though it is not directly linked, it will have an impact. Why? Because, say, you can see the Peruvian Humboldt current, which is one of the, and this particular Brazilian current, which are the two important currents which are affecting the El Nino and La Nina, right? So in this particular region, in case if Antarctic circumpolar current is having changes, so what will happen? Automatically, there will be large amount of temperature change in this Peruvian as well as Brazilian current. Clear? So in that particular way, naturally, there will be a significant impact which it can create on El Nino or La Nina. Clear? Because the surface temperature which may affect. So definitely, say for example, a large amount of cold air water is now slightly changing its temperature. So naturally, what happens to El Nino? El Nino will be more intense than ever before. Clear? So if it turns more colder, then naturally the La Nina effect will be even more worse. Understood? So
Sir,
definitely.
So, sir, is this a new concept or something very
No,
old?
it is not new. We have discovered that recently that this particular Antarctic circumpolar current is so significant that it can alter various climatic systems, right? Already it is there. So we have found that it is happening and it is something serious which we need to take into consideration, right? So it is not that new current is formed in the globe. It is already present. So now we have discovered its significance and implications. That's all. Yeah. Fine. This particular westward drift, that is Antarctic circumpolar current, so it can create upwells, right? So when it create upwells, what will happen? Naturally, nutrient upwelling will be there. That is, nutrients will be circulated at a larger rate. So automatically you have the impact on biodiversity because it can increase biological productivity or it can have other impact on biological productivity. So this is one. And naturally, since it is affecting the global, what do you call the entire global ocean current, naturally it will have an impact on the distribution of the climate or parameter regulation function will be influenced by this particular current. Okay.
Sir, can it change the fate of El Nino? Suppose El Nino
Of
is
course,
all.
yes, it can be.
So, for example, sir, generally this 2018 was a El Nino year for India, but unfortunately, it was also a period of high monsoon. So that's what I have confusion.
That's what it can influence, or definitely it will have an influence. That's what we explained before. Because say this particular change in this current, naturally it will affect the southern hemisphere, right? When southern hemisphere ocean currents are affected, naturally there will be an impact on the air mass which travels upon that particular ocean current, which brings in moisture to India. Clear? So even in El Nino, as you mentioned, there may be some, at that time in 2018, we didn't understand what it happened, why it was so. And you can see La Nina is extending previously. So why it happened? So we had various theories coming in. So with the influence of westerlies, with the influence of various other ocean currents. But now we can see that significant influence would have been posed by these ACC also. Got it? So with further more research, we can understand how it really influences various other factors in future. So in future, when you find it concrete, we can understand, okay, so in the previous years, so this would have been a factor for these erratic behavior of the, what do you call, the El Nino or La Nina. Here. Because it is convergence, right? So you can see there is a convergence here. So in this region. So when convergence happens, so automatically there will be different, what do you call, the changes in ocean current features, it happens, right? So this is one important discovery, and in future you may have news upon them. So especially this year when onset of monsoon comes in case of any changes happen, or floodings, or especially in the North Pacific region, Western Pacific region. So when it happens, so possibly this reference again may come up. Okay. So when it comes in, so naturally you need to add upon ACC as one of the factors affecting these climates. Clear? So definitely it will have an impact on climate regulation, because this flows west to east. Okay. So as a rotation of the Earth, and naturally it connects all major oceans like Atlantic, Pacific with Antarctic. So in that particular way, definitely these, and also Indian Ocean. So naturally it is said to be the only ocean current which is completely flowing across the globe. Okay, so you can see found across the globe. So in that way, naturally that global climate regulation will be naturally influenced by this Antarctic circumpolar current. Clear? Okay. Fine. So this is the second important aspect what we have. Then comes polar night. Okay, so you have polar day, you have polar night. Okay. So what are polar nights?
So due to the tilt of the Earth, so the hemisphere facing the sun will have 6 months of day, and which is away will have 6 months of night.
So it is due to tilt of
Earth on its axis.
Tilt of the Earth on its axis. Fine. So because of tilt, what happens?
Angle of incidence changes. So
angle changes. So angle of incidence of lights changes. So automatically we have the prolonged darkness, right? In case of polar night, prolonged darkness. In case of polar day, so it will be prolonged daylight. Okay, so that will be experienced for a few weeks or few months. Okay, so it is a continuous phenomenon. It happens during which period? Summer or winter?
So winter solstice.
So usually winters. Okay, so winter, and because of the orbit around the suns, when the Earth orbits around the sun, the tilt tries to have this particular prolonged period of darkness. Okay. So which area usually it will have along the Arctic Circle and Antarctica?
Sir, 65 degree to 90 degree.
Okay. So polar region, fine. So usually, because Antarctica, it is completely Antarctica. So no issues there. Whereas in Arctic Circle, where it can be seen much. So it can be found mostly in
Nor
Alaska, then Canada, then
Norway, Sweden.
Scandinavia. Okay. Then Greenland, fine. Then one
So
more.
the Serbian,
Ah.
Siberian.
So Russia's Siberian region. Right. So these region, you have the polar nights which you can have at large. Okay. So the main point here is the tilt of Earth, long nights and long days. So happen. Okay. So this is one we have seen in mentoring, right? So we saw some questions related to tilt of Earth, rotation of Earth, revolution of Earth. Some type of questions are there frequently. So remember, so longer days and longer nights. So one important reason, tilt of the Earth. Okay. Fine. So,
Sir, so there is something I've read about ozone depletion that the CFCs accumulate during the night, and when the polar days come, the reaction is
continuous.
Yeah, continuous, and that's why we have.
Yeah, because the thing is that when polar nights and polar day come in, so since there is a continuous period of exposure, so especially during the day when polar days are there, say automatically more than 12 hours or almost by 24 hours, the depletion happens, right, in daytimes. So ultimately there will be more loss of the thing. Whereas on the other hand, so during the darkness, so accumulation will be more. Whereas so it's a natural phenomenon. So say remember that ozone depletion is not not only a
Human induced.
human induced or anthropogenic thing. So it happens even naturally. So natural ozone depletion is not a big deal because there is a natural method of depletion, there is a natural method of accumulation, right? So that will be normalized. Whereas when you have, apart from natural, when you have anthropogenic factors, so that disturbs this particular cycle. So when you disturb this particular cycle, more depletion happens. That's a problem. Okay. Otherwise, not a big issue will be there. Okay. So when polar nights are there, what are all the influences of polar nights?
Sir, one question, sir. Like in polar nights, sir, more accumulation of ozone happens.
See, sunlight is not there. So when UV rays are largely found, so you have more depletion. When you have less, so naturally it is less. You don't see that it is complete night. So because in stratosphere, you will experience that particular thing, right? So it is not going to be night there. But since what is the logic? Tilt is there, so the intensity of insolation is less. So when insolation is less, so less amount of light is arriving. That means less amount of depletion will happen. That's all. It doesn't mean that it will be zero. Okay. Fine.
But sir,
So
if we have less amount of insolation, sir, so basically the breakdown
naturally,
of
ozone will be less. Right.
oxygen will also not break down. So
And
how
that's
the
what
ozone will form?
depletion will not happen at large.
Okay.
Right. So you will have more of you will have less of ozone depletion. That's the idea.
Okay.
Yeah. Whereas on part of exposure on daylight, that is a polar day, where the tilt will be there in such a way more light is formed throughout. So naturally insolation will be more. So automatically depletion will be more. I'm talking only about the natural phenomena. When you add on with anthropogenical, then it will change that particular aspect. Okay. Say for example, even during polar night, when you have more CFCs emitted, what will happen? So furthermore, depletion will be triggered, right? So with that particular less amount of light, it's Okay, so what is the most important consequence of it?
Sir, aurora.
Okay, fine then.
So the impact on the people living in these areas, their
So
lives.
naturally the behavior. So people and wildlife behavior will change. Why?
So because they have to get accustomed to the darkness, and also like vitamin D is less.
Okay.
So feeding
So,
pattern changes. Yes.
so naturally when you have sunlight only, you have more vegetation which requires photosynthesis. It can happen. Otherwise, what will happen? So photosynthesis in that particular region will not happen much. Only few vegetation will be there, and that too will die because of these aspects. And apart from that, the oxygen balance can be affected. Okay, when photosynthesis happen, you get more oxygen. So unfortunately, you will not get that. And psychologically, that biocycle will be affected, right? So you have biological clock, so morning and evening. So continuously it will be dark. So that will, for a few weeks or few months, what will happen? Think through the time you will have day, through the time you have darkness for a few months or several weeks. So definitely it will affect the people's lifestyle. Okay, fine. So that's a natural phenomenon why we have less amount of vegetation, less amount of biome, less amount of biodiversity in those region. Even human, very less amount of human population survive there. Okay, fine. So these are polar nights which you need to remember. Right. Now we have a new concept of E prime layer. So what is that E prime layer? What is
So
this?
it's a newly discovered layer which is found on the outer core.
So new layer in the outer part of core, right?
Yes, sir. Yes, sir.
So on the outer part of core. Fine. So what is this particular thing happens? So between lower mantle and outer core, we have this particular layer. So why this play or how this particular layer is found? I mean, formed.
So the entry of water, percolation of water deep inside the leads to formation.
So from lower mantle to, so from crust, you have tectonic plates. So because of these tectonic plates, so they allow some surface water to enter into the deeper part of earth crust and then mantle and then to the outer layer of the outer core. Okay. So what happens there? When they go to this particular core mantle boundary, so continuously for billions of years. So what had influenced or what happened to this particular layer? Okay, instability or discontinuity. Okay, fine then. So naturally there will be some chemical change, right? So it will trigger some chemical change in that particular layer. Okay. So this chemical change has directly affected the earth core. Okay, that is what the identification, what they had. So why this particular chemical change happens? Why? Because the water which enters, it will meet the core material. That is the material of the core. So what we have in core, so which is under high pressure. Okay. So already the components of the core is under high pressure. What components we have in core?
Iron, nickel.
So NiFe, right? So these NiFe will be reacting with water. So they are highly reactive with water. So on that too at high pressure, what happens? They have high hydrogen produced. Okay, hydrogen content is produced at high levels, and silicon is low level. Okay, so high level of hydrogen, low level of silicon. So this particular thin layer is consisting of hydrogen and more hydrogen and less silica material. Okay. So these crystals, so they try to form the sheet over this particular outer core. That is what they have identified. Clear?
Yes, sir.
So remember, it is outer surface of the outer core they have made, and it is hydrogen. And how it is happening? Because of the percolation of water for billions of years. And this is because of the crust. That is crust in the sense tectonic movement in the crust. So between the mantle and the core. Okay, so this is a idea. So what they can ask is about the core. They can ask. So the liquid part of the core, how the solid part of the core. So what are they? So outer core, how it is liquid, and inner core, the solidification, how it happens, and the percolation in these area or discontinuities. So what are all the various discontinuities it happens, or simply the earth prime layer lies between mantle and core, or between the outer core and inner core, or crust and mantle. Likewise, the options can be even simpler. So all these are there. Clear?
Yes,
Okay.
sir.
So they won't make it much difficult here. So they'll be typically asking a simple question, but a confusing question will be there. Okay. So try to be clear with the layers of core and mantle and crust. Then phreatomagmatic eruptions. So what are they? Why it is in news?
So either in Iceland or somewhere like.
So
It has
recently
erupted.
Japan. So usually Iceland have recently Japan had it in Ogasawara Island. Okay. So usually Iceland is famous for it. So it is actually a undersea volcanic eruption. Okay. So undersea volcanic eruption. So what happens here? The magma along with water emerges out as a erupted material. Okay. So what is this particular? What are the various aspects you know about these phreatomagmatic eruptions? Hmm? Whether ash will be there? Ash.
Yes, sir.
Why?
Eruptions means acidic.
Obviously, the material will obviously be.
So because of the reaction between magma and water, so naturally there may be ash content, right? So you can see large amount of gases and water as well as the magma. So that particular interaction definitely will have form ashes. So similarly, you have both acidic as well as basic components which we have in this type of volcanic eruptions, right? And whether the erupted materials, when they deposit, whether they are coarse grained or fine grained.
Not fine grains.
Why?
Because as they are not flowing, actually flowing material would be.
Okay. When ash content is there, how it will be?
Fine grained.
So because of this, see here there is a very high pressure difference, right? So when there is a pressure difference and you have both acidic and basic components reacting with between magma and water, so automatically it has finer grains, okay, when compared to other magmatic eruptions, right? So remember that, and therefore we have more fragmentation. So higher fragmentation of the magma will happen. Okay, fine. So apart from this, they may ask you other different types of volcanic eruptions what we have across the globe. So you try to have a basic idea upon it. Okay, and the Pacific Ring of Fire. So those region where the possibilities of these type of eruptions are found. Okay, so that type of questions can also be asked indirectly. So even if they are not going to directly ask in this way, they may have undersea volcanoes regarding that. So how it is formed or how it is, what are the factors involved. So likewise, the questions can be asked. Okay. Right. Then. And similarly, the composition of the flue gases which comes in. So that can also be asked. Okay. Then deep sea mining. So recently, deep sea mining was in news for various reasons, especially for green energy, right? So they were speaking about it for green energy. So I don't know how far it is going to work with respect to green energy. But anyway, so who actually gives permission to deep sea mining?
International Seabed Authority.
International Seabed Authority.
Jamaica.
Right. So ISA. So International Seabed Authority. Fine. So what is actually deep sea mining?
So mining of critical minerals from deep on the ocean.
So what are the different types of minerals you get it? You call it as
Critical minerals.
Polymetallic
polymetallic
nodules.
nodules, right? So polymetallic nodules we have. Okay. So that polymetallic means it consists of different metallic components combined to it, right? So what are the different types of metals you have?
So cobalt, nickel.
Okay, cobalt, nickel, iron, then most of heavy metals and other
Yes, sir.
materials which you have as critical minerals. So it is phosphorus. Okay, fine. Okay, so especially you will be targeting the cobalt rocks. Okay, cobalt rocks, what you have. Okay. So in sea floor, what type of deposits you have? Remember, you have sulfide deposits. Okay, sulfide deposits. And these sulfide deposits are also one of the targets similar to cobalt rocks. Okay, so these are basic things. And what are plumes? I think in mains they have asked once plumes.
So
What are
when the
plumes?
right, sir. So it's known as a mantle plume, and when on the land surface, there is a eruption of magma. However, there is no tectonic boundary at that place. So that is when a mantle plume occurs due to very hot temperatures inside.
Okay. So because of high temperature, we have a smoky a substance like thing which we have inside the deep sea region. Okay, fine. That we call it as plume. Fine. So it is actually again a well of fluid, right? Fine. So what is the important functions of these plumes?
Geothermal energy,
Okay.
like hot waters and all springs and all are coming from
Okay.
coming due to sleep.
Okay. Then anything else?
Sir, they also form islands in non-plate boundaries like Hawaii.
Oh, okay, good. Then, so they have even dissolved materials, right? So they can have dissolved materials, suspended particles. They may transport carbon. Yeah, so carbon can be increased. Okay, then any
The
other?
Indian peninsula has also been formed due to this mantle plumes.
Okay. Right. So these are some aspects what you need to know about plumes. Okay. So same way, the mid-oceanic ridges. So how they will be helpful in deep sea mining and what they can contribute, and similarly sea mounts. Okay, because sea mounts as well as mid-oceanic ridges both are in use. Okay, we have discovered larger sea mounts near US and all. So recently, so we have this particular uh, importance related to this deep sea mining we need to have. And similarly, the depth on which we have. So what all the impact of deep sea mining? So it can be asked in veins. So why deep sea mining is required, and what are the significant impact it can create or damage it can create on marine ecosystem? So likewise they can ask about. So the oil spills or fuel spills, you have a vibration which is created by the machineries, light pollution, noise pollution. Okay, so it can impact a very huge amount of fisheries or marine organisms. So likewise, we have large amount of aspects. And similarly, you have a UN clause which is also there, and related to deep sea mining to have some better uh, sustainability or sustainable solutions to be there with deep sea mining. What is recently uh, put in place international level to have a responsible deep sea mining? Recently, we saw in news also in current affairs.
So the Biodiversity Beyond Natural Jurisdiction Treaty.
So what does it mean? In short, we call it as
A BBNJ.
So I see treaty, right?
Yes, sir. High Seas Treaty. Sorry, yes.
So
High
I
Seas.
see. What you said is right. United
Yes.
Nations Biodiversity is of area beyond national jurisdiction. That is also called as High Sea Treaty.
High Seas
Right?
Treaty. Yes, sir.
So what is its significance? So you need to link it with these deep sea mining also. Okay. Or High Sea Treaty. This is a legally binding treaty. Remember that. So this is a legally binding treaty for the first time. We have it in the area of the biological diversity, especially marine biological diversity. We have a legally binding instrument. Okay. So it is under the UN clause only we are having this particular treaty recently, which was adopted. Okay. So it can be definitely asked High Sea Treaty. So remember that. Okay. Fine. So this is for biological conservation, especially outside the national jurisdiction we try to have. So here they address in this treaty, that is High Seas Treaty, they try to address marine biodiversity. They try to talk about equitable sharing of resources. Okay, so environmental impact assessment in marine areas and so on. Okay, so this is one of the important step towards biological diversity, especially in deep sea aspect. Okay, so remember that already they have asked about international seabed authority recently. So possibly they may ask other parts of these areas. Okay, so where is I mean, what is this particular organization all about and where it is located? International Seabed Authority.
At
Headquarters?
Jamaica.
Jamaica. Okay. So it is established under UN clause and It is an autonomous agency under UN, and it is headquartered at Jamaica, Kingston. Okay. So remember that three things are directly linked to deep sea mining. One is polymetallic nodules. The other one is the C4 sulfide. The other one is cobalt. Okay. Cobalt is in rock, sulfide in the floor. Okay. C4 deposits, and polymetallic nodules is also in the ocean floor. Okay. So we have many rare earth minerals which are there. For that reason, we have deep sea mining. And we also have many programs, right? Deep sea mission and all we have, and we also have even under Ministry of Earth Sciences, we have even Samudrayan, which is one of the important missionaries what we have, and Matsya 6000, which we have, which can go deep as such 6,000 meters to have ocean seabed reading and so on. Okay, all these are linked to this, okay, with the Indian perspective. Anyway, so we have did many advancements in these aspects, okay. So with respect to deep sea ocean under Ministry of Earth Sciences. So just have a look up on that, especially Samudrayan and Matsya 6000, okay, the submersible vehicle which goes underwater for all hydrography as well as survey and exploration, right? So these are some of the main areas with respect to the terms or terminologies which are there. So further on Wednesday, we will try to discuss on the other basic concepts of what we have it in geography as such. Okay. Thank you. Bye.
Thank you, sir.
Thank you, sir.